Hi students, so let us continue solving MCQs on waves chapter based on NEET level. Okay, so we will be doing now question number 31 as per our exercise material. So the question says a pipe of length 85 centimeter is closed at one end. It's closed at one end. Okay, length is 85 centimeter. So it's closed. Okay, so first thing to understand is it is closed pipe. Find the number of possible natural oscillations of air column in the pipe whose frequencies lie below 1250. So frequency should be less than 1250 Hz. Speed of sound in this air is given to be 340. Okay, so since this is closed pipe, any harmonic will have a frequency n times V by 4L or 2L. Closed pipe means it is 4L. And n can be only odd integer because it is closed. Now they want the maximum frequency to be how much? They want the maximum frequency to be 1250. So the air here should not oscillate with frequency greater than this. So maximum value I have substituted. That will give me the maximum value of this number. V is 340 fixed in the problem. Length is fixed. 85 means 0.85. So please simplify this. Okay, it's a simple arithmetic. So if we simplify, the value of n will come 12.5, which means which harmonics will be possible. Remember, n can take only odd values. This is the maximum value. So 1, 3, 5, 7, 9, 11. So how many total? How many total number of harmonics are possible? 6. So right option is E. Okay, if it was a open pipe and you got this number, then it will be from 1 to 12. Okay, because even is also allowed, odd is also allowed. Let us now see question number 32. So an open pipe is suddenly closed at one end. Okay, so maybe they have put their hand or something. Okay, or some cardboard they have used. Okay, so question number 32. So there was an open pipe and now it is suddenly closed at one end. As a result of which the frequency of the third harmonic of closed pipes. So third harmonic of closed pipe is found to be higher by 100 than the fundamental frequency of open pipe. Here it is fundamental frequency. Fundamental frequency means which harmonic? First harmonic. So this is found to be higher than this by 100. They want the fundamental frequency of open pipe. So here this is fundamental frequency. Let us say F1 for open. Okay. This is third harmonic of closed pipe. So third harmonic. That's right. F3 of closed pipe. C let us write. So they are saying this F3 closed minus F1 open. This is higher than this by 100. So the difference is 100. Okay. Now if this is V by open pipe means 12, this will be how much? You remember or not? This is third harmonic. So third harmonic means 3 times fundamental. Fundamental is how much? In closed pipe V by 4L. Right? V by 4L. Isn't it? So they want this, right? So let us express this in terms of this. So I can write this whole thing as 3 by 2 into V by 2L, because 2 I this 4 I can write 2 into 2. So remaining V by 2L here I can write F1 open, right? So here I can substitute 3 by 2 into F1 open minus fundamental frequency of open pipe equals to 100. 3 by 2 minus 1 will be 1 by 2, cross multiply, F1 open will be 200 Hz. That means the correct option will be option A. So simple question again. Next question 33. The third overtone of open pipe of length L0 has the same frequency as third overtone of closed pipe. So here your knowledge of whether you know which harmonics are present in open pipe, closed pipe, and what do you mean by overtones, all that will be very useful. Okay, so you have open pipe and then you have closed pipe. Length of open pipe is L0, length of closed pipe is LC. They are saying third overtone of this has the same frequency as third overtone of this. Okay, now for open pipe, let us remember it is open, so all harmonics are possible, right? Now fundamental is called first harmonic, right? First overtone, because after fundamental the frequencies are called overtone. So first overtone is second harmonic, right? So third overtone will be your first is second, second will be third, third overtone will be your fourth harmonic. Fourth harmonic. Okay. So what will be the frequency of this? Fourth harmonic means 4 times fundamental. Fundamental of open pipe is what? B by 2. Clear, right? Okay. Now this is third overtone of closed pipe. For closed pipe, fundamental is your first harmonic, no doubt. After that is your first overtone. So first overtone, there is no second harmonic in closed pipe, will be third harmonic. Second overtone will be fifth harmonic. Third overtone will be your seventh harmonic. So this will be 7 times fundamental. What is fundamental frequency of closed pipe? B by 4L. But length here is LC. So B gets cancelled. This 2, no, I can cancel these 2. But here 2 2s are 4, right? So they want ratio of L open by L closed, right? So it was multiply L open by L closed. Take L open this side. 4 here. So 4 2 is 8 by 7. So option D. Next question you see, question number 34. 50 tuning forks, sorry 34, okay. 50 tuning forks are arranged in increasing order of their frequencies, okay, such that each gives 4 beats per second with its previous tuning fork. Okay, for that you should remember the formula for beat frequency. So 34th question, there are 50 tuning forks, number 1, number 2, like this, 50 tuning forks are there in increasing frequency. So frequency increases as you go from first tuning fork to 50th tuning fork. Now they are saying each produces 4 beats per second, meaning beat frequency is 4 hertz with the previous one. That means, and they are also saying if the frequency of the last tuning fork is octave of the first one. Now, octave usually you may think is 8 times, but in the language of music literature, octave means double. Okay, the frequency is double. So when the in Saregama, the last sa and the first sa are octaves. So when we say the first sa is little little low pitch, right? Sa like that. Sa re ga ma pa da ni sa. So that last sa is higher pitch. So that sa has twice frequency as the first sa. So they are called octaves. So they are saying this is octave of this, meaning frequency of 50th tuning fork minus frequency of first tuning fork is not minus, is this tuning fork is twice of this. So twice. Okay. So this information is given in the second sentence. Also they told each tuning fork produces how many beat frequency? 4 beats with the previous one. So F2 minus F1 is 4 hertz. Also I can say F3 minus F2 is 4, F3 minus F2. Also I can say F4 minus F3, like that is 4. So that way it's boring to write, right, up to 50th. So from here we can see that if I substitute this F2 here, what is F2 from here? F1 plus 4. So substitute here. F1 plus 4. So F1 plus 4. This minus will make it minus 4, it will come this side. So if you substitute this here, it will become F3 minus F1 will become 8. 8 means 2 times 4. Then if you substitute this F3 here, F3 will be what from here? F1 plus 2 into 4. Substitute here. So this will become F1, this will become 3 into 4. Am I right? Okay, yes. So that means in that way, if you keep going, F50, frequency of 50th tuning fork minus the first one will be how much? This is f4 minus f1 is 3 into 4. f3 minus f1 is 2 into 4. f2 minus f1 is 1 into 4. So this is, I can write 49 into 4. Correct, right? Okay. But f50 we know is twice of f1. This is twice of f1 minus f1 equals to 9. 4 nines are 36, 6, 3 carry, 4 4s are 16, 17, 18, 19. So f2 f1 minus f1 is f1 to 196 hertz. So frequency of the first tuning fork is 196 hertz. Option C. Next question, question number 35. An open pipe is suddenly closed. This is same as the previous question which we have done. So no point doing it again. Let us see now question number 36. In a resonance column experiment, okay, this topic I have covered while doing synopsis. Okay, second video, part 2. So 36 question. In a resonance column experiment, the first and second resonances occurs when the water level is 24.1 centimeter and 74.1 centimeter below the open end. So in that experiment, what do? We take a pipe which is open at both ends, then we put it under a water. Okay. So this becomes now your fixed end. Okay. Or I can say closed end. So it's a closed pipe. So by moving this pipe up and down, you can change the length of the air column, which you are going to make it vibrate. So the first resonance occurs at 24.1. First resonance will look like this, right? This is note, this is empty note. So this length L1 which they have given will be lambda by 4. If you do this, you have done a mistake. That is because you have to consider here end correction. You know that the air here will little bit go outside, so this was your end correction E, which was 0.3 times diameter. So they are asking in the question what diameter of the tube itself. So if you use it this way, the diameter will not come, right? So now once you have understood this, you can write this L1 plus E is lambda by 4. Second resonance occurs at what length they have told? 74.1. So now if you imagine, if you increase the length, okay, then you will get something like this. This is the water level. Okay, little bit will come outside. This is your E, right? So now the whole length, how I can write this length is L2, let's say. So L2 plus E. This is your second resonance. So this is lambda by 4, lambda by 4, lambda by 4. So 3 lambda by 4. You need to find diameter, so obviously you need to find E. So they have given you L2 and L1, right? So what about lambda? Now lambda we don't need also, right? Obviously. So what you can do is, you can, if you subtract this, you can find lambda. Then you can substitute here. Or best thing is multiply this by 3. Okay, best thing. Then you subtract because we don't want lambda, right? So if you subtract these two, you will get this minus this. Let's say you will get 3L2 plus 3E minus L2 minus E equal to 0, right? This is L1, right? L1 is the shorter one, okay? So this will give you 3L1 minus L2 plus 2E equal to 0. So 2, is it visible? Yes. So 2E, if I take this to that side, it will become L2 minus 3L1. L2 is given, right? This L2 is given. So let us substitute. 2E will be, L2 is how much? 74.1, the bigger one, okay? 74.1 minus L2. Oh, sorry, minus 3 times L1. L1 is the smaller line, 24.1. Okay, so that will give you 2E equals to 74.1 minus 3. So, okay, 72.3, right? So then if you subtract this, you will get 74.1, 72.3, 8, 1, right? So it will be 1.8. So 2E will be 1.8. So once you know 2E is 1.8, E will be what? 0.9. And once you know E is 0.9, E is what? 0.3 diameter equal to 0.9. So D will be 3. These points you can remove, 3 3s are 9. So it is 3. It is centimeter or meter. Well, this number 74.1 that we have substituted was given in centimeter. So this will be in centimeter. So correct option is B. Let's see the next question. 37. A guitar string is 90 centimeter long and has a fundamental frequency of 124 Hz. Where should it be pressed to produce a fundamental frequency of 186 Hz? Okay, so where it should be pressed so that it produces a fundamental frequency which is 186 Hz. So let's say this is the guitar, right, guitar string. Okay, so when this is plucked, this is L, let's say L1, and the frequency, fundamental frequency is 124. So this is your 120 fundamental frequency. Like this it looks, right? Now, if you press it somewhere here, okay, you press it here, then this will be your note now. So if you make this oscillate, it will oscillate this way. So this will be your L2, and since the length has become shorter, you know fundamental frequency for a string is how much? B by 2L. It is inversely proportional to length. So if the length has decreased, frequency will increase. How much it has become according to question 186. So since these two are inversely proportional, you can write F1 by F2 is L2 by L. F1 is given, F2 is given. Initial length was 90 centimeter. So this is 90 centimeter. L2 you can find. So very simple question. Next question, let us see. Two vibrating strings, 38 question. Okay, two vibrating strings of same length, same cross section area, are stretched to same tension. So there are two strings, length is same, area of cross section is same, tensions are also same, but they are made of densities. One is rho, other one is 2. So these two are different. All these are same. Each string is fixed at both ends. If V1 and V2 are the speed of the transverse waves in the strings with densities rho and 2 rho respectively, what will be V1 and V2? This is a simple question. Velocity for a transverse is root over T by mu. Well, mu is mass by length. Mass divided by length. We need to write in terms of density because they have given you information about density, right? So mass you can write as density into volume. Any wire will look cylindrical in shape, right? So volume will be area of cross section A, which is pi r square, into L. So L and L will cancel. So we substitute here this mu, it will be rho into A. Now you know tension and area are same. So velocity is inversely proportional to root over density. So velocity in the first string divided by in the second string will be density of the second string, which is given 2 rho divided by rho. So that will be root 2. So option C. 39th question, let us see. A sitar wire is replaced by another wire of same length and material but of 3 times the earlier radius. So this time length is same, material is same means what? Density will be same, right? So length is same, density is same for the two wires. But the radius is 3 times the earlier, meaning if one is R, other is 3R. If the tension in the wire remains the same, so tension is also same, by what factor will the frequency change? Will it be 1/2 of the previous, 2 times of the frequency? Now they did not ask which harmonic, it doesn't matter also, whichever harmonic, it is n times v by 12, which I can write n by 12, v velocity of transverse is root over t by mu. Mu I can write density into area, area of cross section is pi r square. Why I wrote in terms of pi r square? Because radius information they are given. Now you see here everything L, T, rho are same. Okay, so frequency will be inversely proportional to roots r square. Root r square will be r itself. So that means f1 by f2 will be 3r by r because second radius is 3r. So if you cross multiply, or directly we can do, right? Radius has increased 3 times. So frequency will become 1 by 3 times. Okay, no need to waste time. So frequency will be 1/3 of the previous, which is option C. 40th question, let us see now. The velocity of sound measured at a given temperature. So temperature is said in oxygen and hydrogen is in the ratio. The velocity of sound, what is the formula? Root over gamma R temperature by molar mass. So you can see this again in the synopsis video. Okay, this is 40th question. So the two gases are, one is oxygen, one is hydrogen, and both are diatomic. So gamma will be same. This gamma formula is 1 plus 2 by 8. It would be more interesting if one was oxygen and other one was argon, right? Then one will be a diatomic, other one will be monoatomic. So degrees of freedom we know, for mono is 3, for dia is 5. But here both are diatomic, so gamma will be same, temperature is same, radius, sorry, it's not radius, universal gas constant, that is also constant. So V is inversely proportional to root of molar mass. So they want velocity of sound in the ratio given, oxygen and hydrogen. So velocity in oxygen by velocity in hydrogen will be root over molar mass of hydrogen divided by molar mass of oxygen. Okay, ratio ulta filter it will become, because it's inversely. So molar mass of hydrogen is 2, for oxygen is 32, right? So it will be 16, so it will be 1 by 4. So 1:4, option C. Let's see the next question now. Question number 41. The intensity of sound during festival season increases by 100 times. Okay, we should have mentioned increases 200 times. Okay, increases to 100 times initial intensity. That we expect, right? In our country, especially if Deepavali is there, crackers and all, when we use, the intensity of sound has increased 100 times. So I2 is 100 times I1. This could imply a decibel level rise from 20 to 120, 70 to 72 decibel, 100 to 10,000 decibel, 80 to 100 decibel. So you need to now uh, understand the relation between sound intensity in decibel level and intensity. So for that you have to see my video under the playlist waves. Okay, so there also I have mentioned uh, this topic. Okay, I'll share the link in the description. You just click it and try to understand how sound intensity is related to sound intensity level in decibel. Okay, so when you express intensity of sound in decibels, okay, so let us write it as L. Okay, so L is intensity of sound in decibels, then that is given by 10 log base 10 I divided by some reference intensity I naught, which means if I take two different sounds with two different intensity, okay, what would be the decibel difference? L2 minus L1. So if you substitute this, you will get 10 log base 10 I2 divided by I1. Okay, this follows from the rule that log A minus log B is log A by B. So I0 will cancel. So they have given I2 as 100 times I1. So I1 gets cancelled. Log 100 base 10 is 2. 2 into 10 is 20. That means the decibel level increases by 20 decibels. So you can check which option satisfies this condition. So option D, because it increases from 80 to 100 decibel. Okay, let us see the next question, question number 42. So it says two identical sounds A and B reach a point in the same phase. So there are two sounds, okay, one is A and one is B, identical. When I say identical, it means what? Their intensities or amplitudes will be same. And they reach at a given point in phase. So in phase means phase difference. Phase difference will be equal to 0. The loudness of the resultant sound is C. Okay, so after these two will interfere, the resultant sound is C we are calling, and the loudness of C in decibels is higher than the loudness of A. is n decibels higher than the loudness of A. So the loudness of this is n decibel higher than the loudness of A. That means loudness of this sound, LC, let us write in decibels, okay, minus loudness of sound of A is n decibels. So this they are saying, they want you to find this n. Okay. So again, you have to first relate the intensity of these two, because these two are identical. So if I say this is intensity I, excuse me. So if I say this is intensity I and this has to be I because identical, then this will have intensity, let's say IC. Then what is the relation when two waves again for this you have to see the synopsis under the topic interference of waves. Okay, so there I have told when two waves interfere with a phase difference of phi, the resultant intensity is equals to root over that is of amplitude, right? So it was for resultant amplitude we write root over, for resultant intensity it was I1 plus I2 plus 2 root I1 root I2 cos phi. So here the two waves A and B have same intensity. So I, this will be I, this will be I. In phase means phase difference will be 0 degree. So this will be 2I plus 2I. That will be 4I resultant intensity. Now resultant sound they are calling it C, whose intensity I wrote IC. So this is basically your IC. Is 4 times intensity of A. So this is IA. Okay. Now what was the relation? In decibel, the difference in decibel values of two sound is given by 10 log base 10 IC by IA. Okay. So IC we know is 4 times IA. So substitute here 4 times IA. IA will cancel. And they have given log base 10 4, whatever comes here is 0.6. So this is 0.6 times 10 will be 6. That means the resultant sound has more loudness than the uh, sound A by 6 decibels. So answer is 6. This is 6. So right option is D. Right? If you compare this with this. Next question you see, the figure represents 43rd question. Okay, the figure represents the displacement y versus distance x along the direction of propagation of a longitudinal wave. So there is a longitudinal wave which is propagating, and this is the displacement, and this is the direction in which the wave is propagating. This is displacement of the particles in the medium. Okay, so they have shown you something like this. Okay, they are calling this P, this is R, this is S, this is again P, this is Q, and they are calling this R. So they are asking the pressure is maximum at positions marked how much? Marked which point? Okay, is it P, is it S, is it R, or is it Q? So at which point pressure is maximum? There are two ways to do this. One way already I have explained in the not in the synopsis, the advanced topic which is under the playlist of waves. Okay, so there I have explained that here displacement is positive. See, this is longitudinal wave. So particles are not moving this way. Particles are moving parallel to the direction of propagation. Okay, so here displacement is positive, right? So that means particles are getting displaced this way. Here particles have displacement negative. So here particles are displaced this way, which means this end will have compression because air molecules will be compressed here. Similarly, here particles have positive displacement. So here at P it will be rarefaction. So compression, rarefaction. And here you can continue if you want negative displacement. So here will be compression. Okay. So it is very clear that at R there will be compression. Okay. So that is one way of finding out which is the right answer. Another way is, if you see the synopsis, you will find change in pressure is given a minus of bulk modulus dy by dx. I am writing it as del because y can be a function of time also, right? So I want to take derivative of y with respect to x at a particular time, meaning keeping time constant. In such cases, we call them partial derivative. Anyways, the point here is, this is what, if you look carefully, this is the slope of displacement versus position graph of different particles. So at r, you can see, if you draw tangent here or here, the angle made with the x-axis is obtuse. So the slope here and here are negative. If slope is negative, here minus sign is there. That means change in pressure will be positive for which points r. Understood or not? So meaning at r, the change in pressure is positive, means the pressure is maximum. Whereas if you look at points P, if you draw tangent here, it makes acute angle, right? So if it makes acute angle, slope of this yx graph, this will be negative. So dp will be negative. So this will be, P will be your rarefaction. As already I have shown you here, pressure will be less. What about here S and Q? Here slope is 0. So dy by dx is 0. That means dp is 0. dp is 0 means change, not pressure is 0. Change in pressure is 0 means pressure here will be your atmospheric pressure. Okay. So it's a wonderful question. Simple but conceptual. Okay. Quite interesting. So next question, let us see. Question number 43. The figure shows an instantaneous profile. Okay. Instantaneous means at any particular instant of a rope carrying a progressive weight traveling from left to right. Traveling from left to right. Okay. So the figure below shows an instant. So they are the figure they have shown. The figure they have shown, displacement versus position of different particles, looks like this. So this is A, this is B, they have marked, and it is traveling towards right. Velocity is towards right. They are asking, this point A is moving downwards. Option A. Option B, this point, this particle B is moving downwards. This particle A is moving upwards. This particle B is moving upwards. So which is the right answer? Again, to understand this is very simple. See, there are two ways. One is the physical way and one is mathematical. You know the wave is propagating along positive x-axis, right? Which means the disturbance, whatever disturbance has created here, that is propagating towards positive x-axis. Disturbance, okay, not the particles. Matter doesn't move during wave propagation, which means whatever disturbance is here will be here after some time. Whatever disturbance is here will be here. Okay, so this disturbance will be here. This disturbance will be here. So the, and what about this disturbance, right? If this disturbance has reached here, what would be the disturbance here if there was any wave? It would be this way, right? So that disturbance will reach here. So the profile, the waveform will look something like this after some time. Okay, that means this particle has to go after some time, and after this instant, the particle has to go down, right? So its velocity must be downwards, whereas this particle has to go upward. So A is moving downward, option A is correct. B is moving upward, option B is correct. So here multiple options are correct. So this is physical way of finding out. Okay, imagine the same question, but they say the wave is traveling this way. In that case, see what will happen to these 2 points. Let us analyze. Disturbance should go here, right? So this disturbance should reach here. This disturbance should reach here. So this whole disturbance should come here. This disturbance should reach here. This disturbance should reach here. So the wave will look something like this, right? Which means this particle has to go up, right? It was here, it has to go up. This particle was here, now it has to come here, so it has to go down. Okay, another way of doing this is mathematically by remembering particle velocity is given by minus wave velocity dy by dx. Okay, del y by del x actually. So you can see this in our derivation. So if you look at this formula, particle velocity is equals to minus of wave velocity dy by dx. Now at point A, if you look, your tangent makes acute angle, right? So your slope is positive, so this is positive. Wave is also traveling towards positive, so this is also positive. So both are positive. So particle velocity will be what? Negative because of this minus sign, which means it has to go down. Whereas if you look at B point, if you draw tangent, it makes acute obtuse angle, sorry. So this slope will be negative. Wave is traveling along positive x-axis. So this is positive. So plus minus 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 plus. So this particle B should have positive velocity, meaning it should be going upward. Okay, so I hope both ways you have understood. 45th question, you see, the figure represents a longitudinal wave traveling in the positive x direction. Okay, the figure represents a longitudinal wave traveling in the positive x direction. 45th. This it is traveling. Okay. So they are given here A, B, C, D, E. Options are part ABC represents compression, part ABC represents rarefaction, CDE represents compression, CDE represents rarefaction. Again, same way you can do here. If you look, you draw the slope like dP is minus B minus bulk modulus del y by del x. So at B, if you draw a tangent, it makes obtuse angle, so slope is negative. Negative means dP will be positive, so this part represents compression. So part ABC will represent compression. Similarly here, part CDE will represent rarefaction. Rarefaction, okay? Because here if you do tangent, the angle is acute, so slope will be positive. Because of this minus, dP here will be negative. So it means pressure is less than atmospheric pressure, which means rarefaction. So which will be the right option? A is right, option A is right, and D is right. Okay. 46th question we will see. Now we come to Doppler effect. An engine driver moving towards a wall with a velocity of 50 meter per second, okay, emits a note of frequency 1.2 kilohertz. So here is a engine, let us assume. It is moving towards a wall which is obviously at rest. So it is moving with 50 meter per second. Okay, 50 meter per second. And it emits sound of frequency 1.2 kilohertz. The frequency of the note after reflection from the wall is heard by the engine when the speed of the sound is 350. No wind and all. So this question, if you remember, is also there in your NCRT, but in a slightly different form. There a rocket is moving towards a target. Okay. So here this engine is moving with velocity 50. Now see, first you have to break this down into two parts. Okay. For the first part, this is your source and this is basically your listener. The wall will act as your observer. Okay. Let me mention observer. So if you had some, if you were in this wall, okay, the frequency that the wall will receive, f dash, will not be same as this because of relative motion. So what will be f dash? What is the formula? V plus minus VO, V plus minus Vs times the actual frequency. Right? Here, which one is at rest? The wall is the observer, so VO will be 0. So VO is out. Right? Okay. And source is moving with what velocity? 50 meter per second towards or away? It is moving towards. So frequency should increase, meaning denominator should be less, meaning I should write minus. And let's give this some symbol V naught. Okay, V naught. So this I can write as V naught. I can put a number also, but let me keep it here. Is this the answer? No, because they want frequency of the reflected sound heard by the driver. Basically, you have to find frequency of the echo. So now, next part, what will happen? This whatever sound is coming from the wall, that will be your basically the sound which is coming, and this will be your observer. Because now the sound that this person will hear, the driver will hear, will be different from this sound because of again relative motion. So now this becomes your source. So now to find the apparent frequency f double dash, what formula I use? Actual frequency is now f dash, remember. So that will be VV plus minus VO. Observer is moving towards, so frequency should increase. So I should write plus V naught. Number is same, right? 50, 50. So both are 50. So V naught. And this is at rest, so this will be 0. No need to write Vs because source is at rest now. So now what you do, substitute this f dash from this equation to this equation. So when you do that, f dash will be, substitute this here, you will get V plus VO divided by V minus VO times your f. V will cancel when you substitute for f dash here. Okay, please do it yourself. So now you have got the formula using which you can calculate f dash, f double dash actually, the frequency of the echo basically. So V is given 350. So this is 350 plus 50, 400 divided by 350 minus 50, so 300 into F. F was 1.2 kilohertz. So double zero cancel. 3 fours are 0.4, 4 into 4, 1.6. So 1.6 kilohertz. 1.6 kilohertz will be the answer. Okay. So that is a 46th problem. Let us see 47th problem. Another way of doing this is there actually, but I think we can see that some other day. Okay, so let us now see the next question. 40. Okay, we will do it in the next video. Okay, thank you.